Good morning, good afternoon, good evening. This is a re-recording of the Internet Credential Architecture Reference Model tutorial, or InterCredentials as we refer to them. This one features the four-corner model for intercredential interoperability, which I will cover near the end of the presentation. So reviewing the agenda, a little bit of an introduction. What used to be called Raw Credentials, we now call bare credentials. So we start off with the bare credential and bare credential sender-receiver model. Then we talk about verifiable credentials and the verifiable credential sender-receiver model. That leverages us into the issuer-holder verifier model. And once we've seen those first three, the bare credential model, the verifiable credential model, and the issue holder verifier model, that we start to see a bit of a hierarchical taxonomy of credential sender receiver model. So we're going to cover that off in step 5. Then we're going to look at two more variations or two more extensions of the intercredential model. We're going to look at verifiable credentials that have JSON-LD RDF extensions. And in 7, we'll look at our alternative serialization. Structured credentials is an example of an alternative serialization for intercredentials. And lastly, that'll lead us up to the actual Internet Credential Architecture Reference Model, or InterCredential model, and the concept of intercredential blood types. Lastly, we'll close off with a very significant introduction, a very significant addition to this tutorial, the four-corner intercredential interoperability model. So just a quick glance at where we're heading at towards the end of this presentation. So the Internet Credential Architecture Reference Model, or InterCredential model, has two axes, and it's against these two axes that we qualify a broad range of credentials, a broad range of Internet credentials. Verifiable credentials just being one instance, one type, one blood type, if you will, of an Internet credential. This is exactly the same slide as last time. I've just highlighted a couple things in bold. There is the concept of intercredential profiles or blood types. So you see on the top left, there's the VC profile. Below that, there's the BC profile. To the right of the VC profile, there's the LD VC1 profile, the verifiable credential with JSON-LD RDF extensions, profile number 1. To the right of that, there's the LD VC2, which is the verifiable credential with JSON-LD RDF extensions. That's kind of a private profile that DHS leverages a lot in what they do. And finally, we have a couple examples of structured credentials on the right-hand side. So let's first of all talk about what is a bare credential and a bare credential sender-receiver model. So there's always a lot of definitions floating around in the decentralized technology space. This is an attempt to collapse some of them into a couple simpler concepts. So in Web 7.0, the following terms and concepts are synonymous and equivalent to one another. Bare credential, a collection of properties where one of the properties is an identifier. A collection of attributes where one of the attributes is an identifier. A collection of name-value pairs where one of the pairs is an identifier. A collection of the claims where one of the claims is an identifier. A collection of the assertions where one of the assertions is an identifier. So whatever lingo you want, it doesn't really matter. You can see that they're all the same, and they're all intended to be the same. If we look at the footnote at the bottom, a bare credential by default is not a verifiable entity, unless, of course, the credential has a verifiable proof associated with it. So by definition, not all bare credentials are verifiable. Only the bare credentials that have a verifiable proof or signature are considered to be verifiable. Let's look at the bare credential sender receiver model. So on the right here, we have an agent who wants to send a bare credential to a receiving agent on the left-hand side. So what are the 3 steps that a bare credential sender needs to do? It needs to create the credential. It needs to auth encrypt the message and the credential attachment, and then it needs to send the message over to the bare credential receiver. What does the bare credential receiver need to do? Well, he or she has 5 steps: receive the message, decrypt it, verify the sender, detach the credential, and then process the message contents and the credential through some sort of business workflow or middle tier logic, whatever is appropriate for the type of the message and the type of the credential. Here, when we look at the Web 7.0 Trust Spanning Layer framework, where do bare credentials live? Bare credentials live in layer 2, the trust spanning layer. They are as basic a concept as possible, as generic a concept as possible as DIDCOMM messages and DIDCOMM messaging itself. And so it belongs in the thin part, the neck, if you will, of the hourglass model. Let's take a little baby step, a little more sophistication, and look at how these are slightly different. So when a bare credential has a verifiable proof associated with it, as well as some other additional metadata, the credential is referred to as a verifiable credential. All verifiable credentials are bare credentials, but only bare credentials that have an associated proof are considered or can be named or typed verifiable credentials. And we can see in the top right-hand corner that the InterCredential type is VC for Web 7.0 verifiable credential. How does a verifiable credential sender send a verifiable credential to the verifiable credential receiver? There's one additional step on each side of the sending-receiving diagram. On the right-hand side, the sender, the verifiable credential sender, needs to create the credential and sign it, auth encrypt the message and the verifiable credential attachment, and send the message. So the only additional step here is step 2, where we're signing the credential, we're attaching a verifiable proof, a verifiable signature to the credential before we auth encrypt it and send it across to the receiver on the left. What does the receiver on the left have to do? They have to receive the credential, receive the message, decrypt the message, verify the sender, detach the verifiable credential, verify the verifiable credential, and then process the message and verifiable credential through the appropriate business workflow or middle tier logic. So here, if you have an astute eye, you'll notice that the only additional step is step 9. Steps 5, 6, 7, and 8 are the standard steps that we do for a bare credential. Once we have the credential, though, we need to verify it if the case is that it's a verifiable credential, that it has a proof, a verifiable proof attached to it. So where do these belong in the Web 7.0 trust spanning layer framework? Well, they're in layer 3, the trust tasks layer. They're no longer part of the trust spanning layer. They're not part of that middle tier, that neck on the hourglass where through which all communications needs to pass. They're built on top of bare credentials, so they belong in that layer 3 trust tasks layer, and we see them highlighted there. Let's look at one more model, the issuer holder verifier model. People are familiar with. So here's the issuer holder verifier model from the Wikipedia article by the same name. And let's see how the verified credential sender receiver model is. So on the left hand side, an issuer is just a special instance a derivation, if you will, of a credential sender. And it's going to send that verifiable credential to the holder. And the holder is just a specialization or a derivation of a credential receiver. Everything that we know about verifiable credential intercredentials applies here. And we can see in the top left-hand corner, the intercredential blood type is VC. What about the right-hand? Here on the right-hand side, a holder is just, again, a specialization or a derivation of a credential sender. And this time it is sending a variation of a verifiable credential called a verifiable presentation. It is being sent to the verifier. The verifier is just a specialization or a derivation of a credential receiver. So the left-hand side is symmetric with the right-hand side, and it's all based on the idea of the verifiable credential sender-receiver model. Where do these fit into the Web 7.0 Trust Spanning Layer framework? They, again, are derived from verifiable credentials, so they have to be at least in layer 3 or higher, but they are here. The issuer holder verifier model is here in layer 3, and it is in turn is based on the verifiable credential sender receiver model, which in turn is based on the bare credential sender receiver model in layer 2. Okay, so let's look at this idea of a hierarchical taxonomy of credential sender receiver models. So what we've seen so far is the issuer holder verifier model is a specialization or derivation of the verifiable credential sender receiver model in the center, and that the verifiable credential sender receiver model is in turn a specialization or a derivation of the bare credential model at the bottom. Let's see if we can explore this hierarchical taxonomy idea a little bit more. Let's look at 2 more examples. Here's the idea of issuing a purchase order and using verifiable credentials to embed or to represent that purchase order. So on the right-hand side here, we have ABC Grocery. On the left side, we have David's Cabbages. And ABC Grocery wants to send a purchase order over to David's Cabbages to order 10 cabbages. And so at the bottom, you can see the purchase order verifiable credential, and you can see its blood type is VC. And it is sent by ABC Grocery's DIDCOMM agent, and it's received by David's Cabbages DIDCOMM agent, and very similar to really what we've been talking about all along. So presumably it fits in nicely into the hierarchy. Here's another example, issuing a vaccination credential. So we have the vaccination authority on the right, a health services organization or an HMO or some sort of government organization is issuing a vaccination credential represented as a verifiable credential, blood type VC, and that's received by Alice. That's her vaccination credential. And so the vaccination authority's software agent is going to send that DIDCOMM message with the vaccination verifiable credential attachment over to Alice. That will be received on Alice's service endpoint. And again, we have safe, secure, trusted communications of that healthcare information. So how does this fit in to the hierarchical taxonomy of verifiable credential sender-receiver models? Well, if we issue the purchase order, if we look at the issue purchase order model, it's really just almost the same as the left side of the issuer holder verifier model. So the issue purchase order model is just yet another specialization or derivation of the verifiable credential sender receiver model. On the right-hand side, the issue vaccination credential is also just a specialization or a derivation of the verifiable credential sender-receiver model. In the center of the diagram, and as we've discussed before, the verifiable credential sender-receiver model is just a specialization or a derivation of the bare credential sender-receiver model at the bottom. So again, we come back to the Web 7.0 trust spanning layer framework, and we can see that the issue holder verifier model, the issue purchase order model, and the issue vaccination credential model are all in layer 3. They are all examples of trust tasks. They all derive from the verifiable credential sender-receiver model. The verifiable credential sender-receiver model, in turn, is a specialization or a derivation of the bare credential model. So let's continue. So here's 2 more examples. This is looking at verifiable credentials that have JSON-LD RDF extensions, and how does it fit into the hierarchical taxonomy, and also how does it fit into the trust spanning layer framework. At the bottom, we see the credential. In this case, it's just any credential sent from Alice to Bob using the JSON-LD RDF extensions to the verifiable credential model. We can see the blood type is LD VC1 or LD VC2. We'll explain that in a moment. We also have the concept of structured credential models, which just represent, we aren't going to talk specifically about what a structured credential model is, but just know that it's an alternative serialization, alternative JSON serialization for verifiable credentials. And so again, Alice wants to send a structured credential to Bob, wants to send some data to Bob that's in the structured credential format. And so we see that represented at the bottom there by the structured verifiable credential. And of course, its blood type is structured verifiable credential. We've looked at the issue purchase order model and the issue vaccine credential model. The verifiable credential with JSON-LD RDF extensions is really just yet another type of verifiable credential. It's an extension to the canonical verifiable credential sender model that we've described at the beginning of this tutorial. Structured credentials, again, is just an alternative serialization of the verifiable credential model. And so it too is a derivation of the verifiable credential sender-receiver model, which in turn is a specialization or derivation of the bare credential sender-receiver model. Now we've got through all that, we have 2 important concepts to finish this tutorial with. One is talking more concretely about the Internet Credential Architecture Reference Model, or InterCredential model. And the other thing is the 4-corner InterCredential interop model. So whenever you're designing an architecture reference model, you need to decide on what the dimensions are for organizing the concepts into an architecture reference model. So in this case, for internet credentials, the first dimension is, does the credential have a verifiable proof? So is the credential derived from bare credential and has no verifiable proof, or does it have a verifiable credential, has a verifiable proof, and hence is a verifiable credential? So that's one way of separating the different types of internet credentials that are out there. In step 2, we can ask, does the verifiable credential have at context JSON-LD RDF support? If it does, then helps us categorize that particular class of internet credential. In number 3, does it have both at context and at vocab JSON-LD RDF support? In that case, that gives us another special bucket of internet credentials. And in bullet number 4, does the derived or specialized credential use an alternative serialization format like structured credentials? There's also other candidates, other additional dimensions that could be used to enhance the internet credential architecture reference model, such as the different cryptographic suites that are used, credential authentication, etc. So again, we're back to the internet credential architecture reference model, a 2x4 matrix. We're going to look at this version of the matrix. It's exactly the same as before, but we've highlighted the internet credential profiles or the InterCredential blood types. So starting in the bottom left-hand corner, we have a bare credential. It's a credential that has an identity as one of its attributes or claims or properties. It does not have a verifiable proof. You can see that on the horizontal or on the vertical axis. At the top of the vertical axis, we have the VC profile, which is a verifiable credential. It's a bare credential that has a verifiable proof. Going from the VC profile one step to the right, we have the VDLC1 profile, and that's a verifiable credential with only the at context JSON-LD RDF extension. To the right of that is the LDVC2 profile, which I call the DHS profile. It's the verifiable credential profile with both JSON-LD RDF extensions. That is, it has both at context and at vocab. On the right-hand side is an example of extensions to the InterCredential model where we're using alternative serialization formats. So we can see at the bottom right, we have SBC, structured bare credentials. So it uses the structured credential format, but it does not have a verifiable proof. Above that in the top row, we have SVCs, which are structured verifiable credentials. They use the alternative serialization format, and they do have a verifiable proof associated with them.
To make the previous models a little more concrete, here's 4 examples. Starting in the bottom left-hand corner, this is a bare credential rendered using JSON. So you can see that it has an ID and a type and a credential subject, and then a list of 4 attributes, one being the identifier for the subject. The intensity of the red, the intensity of the green, and the intensity of the blue. Above that is a transformation of the bare credential into a verifiable credential, again rendered in JSON format. And so it's really just the addition of the proof in lines 10 through 16. Moving to the bottom right, we have a structured bare credential. Remember, structured credentials is just an alternative serialization. So it's the same data that we see to the left in the JSON bare credential, but serialized as a structured credential. And so in a structured credential, we have the concept of an envelope. An envelope has a label for storing the metadata, and it has content, which is the subject and the ID. And then we use the claims word to box off the actual credential attributes themselves. Going to the top right, the last example here is a structured verifiable credential. So it's the same information to the left in the JSON verifiable credential abstract data object, but this time it is rendered as a structured credential. So again, we have the concept of the envelope, the label, and the content, and then on the envelope we're attaching a seal or a proof, so that we're able to determine if any of the data, the label or the content, has been tampered with. And those are your 4 examples.
The 4-corner InterCredential interoperability model. This is brand new in this presentation. So a few comments about interoperability in general. So if you have a niche specification that only interoperates with itself, it's not really a useful definition, example, or showcase for interoperability. And I think that's what we're seeing so far in the version 2 of the W3C Verifiable Credential specification. The true test of interoperability is the ability to interoperate across multiple credential formats, multiple protocols, multiple transports, etc. And hence the answer to this latter scenario is the 4-corner InterCredential interoperability model. The 4-corner InterCredential interoperability model is based on a white paper authored by a colleague, Ken Holman at Crane Softrights in Ottawa. The title of Ken's paper is a case study of a semantic library underpinning the 4-corner model for document exchange. It's an example of how there was a problem readily exchanging UBL, Universal Business Language documents, and how the 4-corner model is used to facilitate rapid, efficient, cost-effective exchange of those complex credentials. There's the URL. It was presented just this past November at the Declarative Amsterdam conference. I've extracted several figures from Ken's picture, from Ken's white paper. So first of all, we have the sender on the left and the receiver on the right. And, historically, there's been the exchange of paper or the exchange of faxes. And that was what we see illustrated here. The sender's data model went into the sender's application on the left. It was printed out in the sender's format, sent as a business document where it was scanned and transcribed into the receiver's application and the receiver's data model. And so this is what we're trying to fix. This is really the core problem we're trying to fix with InterCredentials. The way people initially tried to solve this problem was to create intermediate service bureaus, and governments flocked to these service bureaus. And those service bureaus were responsible for receiving all the different kinds of invoices, for example, that were destined, let's say, to the U.S. government. That service bureau, run by large consulting companies, made lots of money transcribing those different formats from all the different senders, from all the different invoice originators, and then the service bureau was responsible for transcribing those into the receiver's data file format to be received by the receiver's application. And so this would have been, the standards issued by, for example, the U.S. government. So all kinds of problems here in terms of residency of data, self-sovereignty of data, but a classic way that this problem was solved for decades. And one way to solve it was to stipulate a particular format, a one and only format, common format for interchange. This is the DHS Verifiable Credential Model strategy. So if anybody wants to integrate or communicate with DHS, they need to use the DHS version of the Verifiable Credential Model with all the additional support, additional complexities of dealing with the JSON-LD and RDF extensions that the DHS profile, the DHS model prescribes. That's called the 3-corner model. The four-corner model says if I'm a sender, I want to work with my file format, with my data model. But I could work with a third party who's able to establish an access point, a sender's access point. So we're on the middle of the left side of this diagram. A sender's access point that understands my format. And so I send and receive data on the sender's access point just as if I was talking to one of my own internal systems. And it's up to that access point to do the translation of that sender's data format into a common generic interchange format. And that's what gets transmitted across the bottom as part of a document exchange. The sender's access point document exchange sends that universal format over to the receiver's access point document exchange agent. And then that agent makes that available to the receiver's access point, and it's the receiver's access point that then takes that universal format, translating it back into the format that the receiver's application wants to use, and everything works. This is called the four-corner model. In reality, there aren't probably not even thousands or millions of different kinds of invoice formats. So the number of different sender access points and the number of receiver access points is not that great. But we get away from the problem of having a central honeypot where data is exchanged and having to force everybody to retool their systems to use some sort of universal format. It's worth mentioning here that it doesn't have to be a single universal format. The sender's access point and the receiver's access point just have to agree on some sort of common denominator access point. So if both the sender and the receiver are using bare credentials, they can use bare credentials. If one's using bare credentials and one's using verifiable credentials, then it's the responsibility of the sender's access point to transform its bare credential into a verifiable credential. Similarly, if the sender is using verifiable credentials and the receiver is using LD-VC1 credentials, then it is up to the sender's access point to do the transformation of its verifiable credential into the LD-VC1. But this is something that can be done as a service. It can be done without creating a central service or a central honeypot. It works very, very well. The original prototype or pilot operation was a project called PEPPOL. We see it illustrated here. We have private companies, private organizations sending their business documents to an access point offered by a service provider. And we see a public institution, a government office, similarly sending and receiving documents from its access point. And in the middle, those two access points have set up roaming agreements, SLA requirements, standardized processes and documents, standardized profiles, registry infrastructures, and federated trust. So this is a very simple example, and not only that, on a peer-to-peer basis, this four-corner model extends very easily, efficiently, and with little additional cost. We can see that represented here by we've added additional private companies that are sending their credentials to the public institution on the right. We can also see that a private company doesn't have to have their own access point. Access points can be shared. They can be a shared service offered by a service provider. Let's start to make this look like a DIDCOMM ARM-based solution, a Web 7.0 solution. So if we take this standard model of the diagram of the four-corner InterCredential interoperability model, And we use a series of DIDCOMM agents to represent the senders and the receivers. In this case, the senders are on the right-hand side, as is our convention in Web 7.0, and the receivers are on the left-hand side. So coming down the right-hand side, we have ABC Grocery creating, let's say, a purchase order using the VC Verifiable Credential blood type. ABC Grocery is going to send that to access point B using its native Verifiable Credential type VC. That access point is going to transform that type VC credential into an LD VC1 credential because that's the agreed upon exchange format. Across the bottom, we can see that once that right side has the LD VC1 credential, once that access point has it, it simply drops it down into the credential exchange agent. And that credential exchange agent is going to send it using DIDCOMM across to the left-hand side. And that's going to be received by credential exchange agent A that's paired with access point A. Access point A is going to receive the credential, and it's responsible for taking the LD VC1 formatted credential and just passing it straight up to David's Cabbages, because David Cabbages as part of the contract understands LDVC1s. So this works very slickly, and of course if anybody had yet another format, that's just another access point that needs to be added to the diagram.
Well, in the previous slide we saw the four-corner InterCredential interoperability model. And I wanted to highlight actually a little bit of a problem in that model. On the right-hand side, we can see the sender side of this message passing, where ABC Grocery is preparing a purchase order invoice. Natively, it's using InterCredential type VC, but David's Cabbages, through their agreement, wants to use LDVC1 InterCredential type. And so following the four-corner credential interoperability model strictly, the one described by Ken Holman, you would have the DIDCOMM agent here in the middle of the blue box, and you'd have the InterCredential exchange agent at the bottom of the blue box. From a DIDCOMM agent, DIDCOMM messaging perspective, particularly the signing and re-signing of the verifiable credential after it's been transformed, and then the signing and re-signing of the message to which it's attached, it becomes a little bit cumbersome, just to leave it at that. So we can improve on this design. And the way that we improve on it is using something called DIDCOMM agent logical composition. So these slides additional slides were created in Houston, Texas. They were narrated in Calgary, and they're going to be uploaded in New York City today just because of my schedule. So let's take the DIDCOMM agent logical composition concept and apply it to the four-corner InterCredential interoperability model. So here is what lies behind the DIDCOMM agent logical composition model. Suppose you have n DIDCOMM agents connected serially. And when I mean serially, from a message transfer perspective. So if we look on the right-hand side in the blue box, we have on the ABC Grocery sender side, we have 3 agents in a row. And also on the David Cabbages side, we have 3 agents connected serially in the opposite direction. So whenever you have that, and whenever they're running underneath the same set of keys, the same identity, it's possible to collapse those. So the scenario on the right can be collapsed or recoded as 2 single physical DIDCOMM agents with n inbound service endpoints each. So we can see that the three agents on the right side in the blue box of ABC Grocery can be collapsed into the rightmost agent on this slide, and similarly the three agents, DIDCOMM agents that are part of David's Cabbages, they can be collapsed into a single agent with multiple endpoints. So we have the access endpoint for both, and we have the credential exchange endpoint for both. And so that leaves us with the four-corner InterCredential interoperability model under the guise of the DIDCOMM agent logical composition model. We end up with two agents, conceptually architected and designed the same. They have two endpoints, an access endpoint and a credential exchange endpoint. So let's step through the previous scenario where the sender on the right wants to send an invoice to the receiver on the left. So the first thing that happens is the credential is created by the sender. In this case, ABC Grocery uses a credential of type VC. So number one there, from the outbound processing from the origin endpoint of the sender agent, it's going to send that VC credential to its access point. And remember the role of an access point, whether it's in the logical composition model or whether it's a separate discrete agent, is to transform the previous credential into a new credential type. So in this case, the access endpoint A is going to transform it from a VC to an LD VC1 because that's part of the agreement with the receiver. Then the next thing that's going to happen after the access endpoint A has transformed that VC internet credential type into a LDVC1 internet credential type, the outbound origin of the sender is going to send that over to the credential exchange endpoint of the receiver. That's step number 2. Then step number 3, on receipt of that LDVC1, for completeness, the receiver is going to send it to its access endpoint for potentially further transformation. But in this case, we already know that LDVC1 is the common denominator credential format. So in fact, number 3, although it will physically take place or could be optimized out, is in effect a no-op.
So a few conclusions. We've seen the Internet Credential Architecture Reference Model, and we've also seen the four-corner Internet Credential Interoperability Model. These are both proposed as an overlay on top of the existing Verifiable Credential Data Models, the W3C Verifiable Credential Models. It's not really intended, the InterCredential model is not really intended to be a new VCDM specification, only an overlay, but there's nothing preventing it from becoming its own, what I call poly-specification, a specification that transcends multiple specification organizations, multiple specifications, and multiple technologies. So when you have a poly-specification, where's the best place to incubate, give birth, and nurture this credential? Is it the WC3? Is it DIF? Is it TOIP? Is it some other organization? Is it a new foundation? So that's the big question, I think, is where should Internet Credentials, the Internet Credential Architecture Reference Model, and the four-corner Credential Interoperability Model be nurtured?
So a last-minute addition to this tutorial on Internet Credentials is the concept of the InterCredential composition model or software pipeline. So on the left side, you'll recognize that that's the InterCredential architecture reference model. In the middle, we have different cryptographic proof suites that are used to compute digital hashes and signatures and also to perform verification of those signatures and hashes. And on the right side, we have different credential data model serialization options. JSON serialization, structured credential serialization. We've seen examples of those two earlier on when we were talking about bare credentials. JWT, of course, is popular, and the up-and-coming, Caesar serialization. So the idea here of the composition model is you start on the left with your credential abstract data object defined from a credential abstract data model. So bare credentials, verifiable credentials, LD VC1 credentials, and LD VC2 credentials all have their own abstract data model associated with them, their own set of properties. Think of a SAC, if you will, that has these claims, assertions, attributes, name, value pairs, properties that are used to describe this particular credential, particular type of credential. And to that bag of properties, we want to use the properties first to create a hash and a signature, and we're going to put those in the bag. And then the second blue triangle there, serialization, is where we take the data that's in the bag, the different attributes and properties, as well as the cryptographic abstract data, and we serialize it. We use one of the 4 or probably more serialization options that are available. So, plain old JSON, structured credentials, JWTs, or Caesar. And this is here just at the end of the deck. It's quite new and quite fresh and may undergo some changes, but I think it's an interesting not only way of layering, looking at the layering of intercredentials, but also to look at it from a process or a composition model perspective.
So if you have any questions, just tweet those to Freddy Architect on Twitter, either a direct message or as a tweet, and we'll get back to you. And thank you for listening for the last 36 minutes to this tutorial on Internet credentials, aka InterCredentials, what they are, how they evolved as a taxonomy, hierarchical taxonomy of credential sender-receiver models, and how the four-corner model can be used as a model for intercredential interoperability. Thank you.